Okay, so this is lecture 15/16. Depending on the slides, I will probably use some of the slides in the next lecture as well. And for this one, I'll probably not do the 5-10 minute lessons. I'll probably do a couple of longer um, lessons or lectures on one on Memento and one on command. Okay, so you have a little bit more detail about this, so you can think about this for your assignments. I'm working currently on a short demo that implements both, and I'll give that to you. Okay. Unfortunately, as I said to you before, over the last couple of weeks, I lost some material, so I needed to re-record, and I even lost my examples. I cannot find them anywhere. I've even checked my time machine. I don't know what's after happening. I've put them somewhere and I can't find them, and I have too many external drives. So anyway, so so I'll probably just give a bit of a longer talk about this in lecture 16, two maybe half-hour slots, 25 minutes instead of 5-10 minute ones. So I get those done later today when I finish the examples. But so that's why we're looking at 15/16 here. Okay. So we're going to learn about software design patterns, but we learn about two different behavioral design patterns called command and memento. And you've encountered these already, as I've mentioned already in the intro to this, that you were asked in your assignment to be able to do an undo and redo facility. And there's generally two ways to do this. There are many ways. There are two core ways to do this. One is the command method, and one is the memento. And we'll come to that a little bit later in the lecture about the different approaches between those. Okay. So for this particular section of the course, I will be recommending a textbook. And the book that I recommend and the book that I use is one called Dive into Design Patterns by Alexander Shvets. Okay, so I use lots of examples from this particular textbook. It's very, very accessible and readable. It has an accompanying website that gives lots of examples in C#. In fact, it gives examples in all languages that you might be interested in using OO development. So the website accompanying this is called refactoring.guru. But look, guys, you don't actually have to buy the book, okay? But if you did want to buy the book, there was a COVID special for €10. It wasn't expensive as a book. It's an ebook. It's quite good. I bought it. I use it, but everything is pretty much there in the refactoring.guru website. And there's a sub-microsite called refactoring.guru/design patterns. And then you can actually see lots of examples with C as well. So let me just see if I can find this for you. I think I downloaded it. Did I? Classes. Yeah. So this is the refactoring.guru website. There is some premium content available here, and that's if you've bought the book, so you can get in and see what's happening in the book. You don't need to buy the book. You can just work through it as well. Most of the stuff that I use and see will be fine from here. There is that section on design patterns which you can click through to, and there's lots of examples, and it tells you all about, you might need to know about design patterns, the different kinds of design patterns that we have, and then the individual links. I also use this book here, or this article on design patterns, modeling in UML and implementation using C#, and by Dr. Zhao, and it's really, really excellent article to read. It gives you a brilliant summary. But for now, and if you look at, for example, we'll get to these a little bit later, the command pattern, and we'll look at the command patterns in C#. But you have other programming languages available here that you can actually use and implement too. So it's a really, really excellent resource, and I'd certainly recommend using and perusing the site. As I said, you don't need to buy the book. Most of the stuff that I do, I'll describe for you in class, but I'll give links and you can go through to these, and it'll be really good. Okay, really good. I tend rarely to recommend books, because lots of stuff that you can get online, lots of free, lots of good free materials, and then there's lots available in the library that you can actually check as well. But this one is just so good, and for the price, it's excellent. So I'm really, really pleased with it. Anyway, As I said, it does give premium access to the forums and all that kind of stuff. You don't have to buy it, and it's just my recommendation. I get nothing for recommending, by the way. This is, I just think it's a good book, and I rarely come across one book that does everything, and this is it. So super stuff. Right. So, like in terms of design patterns, then, so what's happened over the years is that with OOP, we find that we encounter the same kind of problems all the time. We end up having to do the same kinds of things all the time, And so what happens is that over the years then, we've developed some kind of best practice. And these design patterns then represent the best practice used by experienced OO developers. So design patterns, they're solutions to general problems that software developers have faced during their development experience. They've been obtained by trial and error by numerous software developers over a substantial period of time. So these are approaches that work, okay? It's not like somebody set out about and tried to say, let's have a formal pattern that does this kind of thing. This is how it works. These are things that work, and then we abstract them in a general way and see, can we make them work in lots of different scenarios? Like undo, redo, for example. Yeah, we always need to have these undo and redo scenarios. Okay, and there will be different approaches to doing these. But and sometimes you may find that one works well for you and the other doesn't work, and a different pattern works. So if you wanted a definition then in some respects, and as I said, this was a brilliant article here, as I said here by Dr. Chow, on design patterns, and it tells us that design patterns are reusable assets that encapsulate the OOD principles, such as low coupling, high cohesion, and embody design knowledge with regard to identifying class-object collaboration, responsibility distribution among the objects, etc. So some of the key features that we have in terms of design: low coupling, high cohesion. And we talked a little about that. I talked about some of that lessons with Solid. So I really like the description from Ji Zhao. The summary, as I said already: often designers are overwhelmed by the options available. The experienced designers make good designs by applying reusable and flexible design solutions called design patterns, and that's it. If you were to ask a really good summary of what these design patterns are, that's it. If you're trying to build something in electronics, or you're trying to build something, like a house or something, you have patterns and plans in place. Same thing happens with software. And what's important to realize is that we end up describing these patterns using the UML a lot of the time. But then there's sometimes this disconnect that students have, where they don't actually see how that pattern in UML describes what's actually what they want to do. So one of the reasons that early on I had you guys looking at UML and generating UML from your code is so that you get that UML picture and UML perspective of what actually you've developed and what the design looks like. Okay, so I wanted you to be thinking about the design. I wanted you to look at your own code and then go forward as well to look at having a design and generating code from design with a view to seeing and preparing you for design patterns that follow. Okay, so in OOD, this design pattern is a general repeatable solution to a commonly occurring problem. So the point that I suppose that we really have to be aware of is that a design pattern is not a finished design that can just be directly transformed into your code. You have to actually make it work for your context. So we can say, yeah, we can have a generalized, we know what happens with an undo and a redo. So if we have an image or something, a graphic, and we add something to that graphic, when we know that the undo takes it away again. And then the redo will add it back in again. And undo, redo, undo, redo. And then, so we know that that's how it works, but that would be very different to, say, taking a list of menu orders. So you go into your favorite website and you're ordering, pizzas or something, and then you're adding all your toppings to this pizza before it gets the order submitted, and you say, yeah, I want this, and I want this extra topping, I want this extra topping, and then you say, no, that's too many carbs for me today, too much protein, I'll undo, and then maybe you think, oh no, hold on, sure, I'll have more, and I'll add more and more. And so, but essentially, it's the same generalized pattern, but the program that you're actually using to generate a pizza ordering system is going to be different from the system that you have for drawing graphics. like your SVGs, for example. But the principles are the same. And the design pattern is the same for the undo and redo, but you're dealing with different objects. And you're dealing with different class structures. Maybe dealing slightly differently with how the menu system operates. You know, you're very much controlled by the web interface in terms of add or remove, point and clicking. But if you're looking at graphics, you have this direct manipulation interface that's very complex. So you have to think a little bit about how it works. You have to think about, and you have to decide how the pattern gets from its specification into your finished code. So really it's a description, it's a template, how to solve the problem, and it gives the best practice based on existing knowledge and experience. They're like pre-made blueprints that you can customize and solve some recurring problem in your code. They're not algorithms, okay? They're not algorithms. They're high-level descriptions of some kind of solution. And you have to learn how to read them. And it's not trivial, you know, but you get there, okay? You cannot just find some pattern and copy it into your program. You have to, you know, like it's some off-the-shelf library, okay? Hoping that it'll work for you. You have to make that extra step, okay? It's gonna work, you know. And sometimes, you know, you might have a different structure. Each of you would have a different approach to how you would have done your assignment. And you might implement an undo redo for your assignment, and your buddy says, you know, the deadline's coming, can I take yours? And you say, of course, you know, I'm a generous person, here, take mine. And then you find that, like, you know, you can't use your buddy's solution because, you know, it's your underlying core structure was different. So then you have to take his whole program, and then we make a comparison and find that both of them are the same, and we fail you, you know. But like, because, you know, people's designs are unique to them, you know. In fact, we fail both people usually because, you know, well, we don't always fail both people. We just mark one and divide the mark by the number of people that submitted it, and unfortunately, that tends to bring the mark down. But what you need to realize is that your assignment and your structures and your coding have signatures that embody you, because you're taking the solution or the design and then building your version of that. And it very much reflects you and sees you. You see you in the pattern. Like when I write my code, I see me in the code, okay? I know how it's written, variable names, structures, the way I implement stuff, because it's my interpretation. I know this, you know. So something to be absolutely really clear about is the pattern's not a specific piece of code, it's generalized concept for solving this particular problem, and you can follow the pattern and implement a solution that suits the realities of your own program. So there's, even though it's a pattern, there's room for individual creativity and so forth here, okay? So there are 4 essential elements to every design pattern. You know, there's a lot of words around this beginning of this stuff, and, you know, you think, oh, get on and show me the pattern, but like, you need to be understanding how they get there, okay? So the pattern has a name, and that's something succinct to describe the design problem with its solutions, its consequences, and it also gives the intention detail. What's the intention for this pattern? It talks about the problem or the motivation, and that describes when you want to apply the software design pattern, okay? When do we need to apply this one? It gives you a solution and a structure. That describes the different elements that make up the design, the relationships, the responsibilities, collaborations. And when we're talking about responsibilities and collaborations, relationships, remember, you need to start thinking back to the UML here, you know, okay? Because we talked about those when we encountered UML. And also the consequences, the results and the trade-offs that are associated with applying the software design pattern. Because if you may have alternatives. Like, for example, I'll tell you now, we're coming to Memento and Command a little bit later. And they are the consequences of the approach for your development and your design. So if you think about what the command pattern does, you think about the ways that you can do an undo and redo, okay? Even in relation to the pizza stuff and the graphical design stuff, program that you're working on. If you have a command-based system, you can record all of the commands. So you know what commands were done, and you just undo the command. So you need to maintain this list of commands. So add this, remove the, add this, add this, add this, remove this, add this, remove this, add, remove, 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 you know. So you're maintaining this list of commands. And you might, so it means that for every command in the system that you build, you have to know how the command works and how it undoes, it unworks, if you like. Now you need that for every single command. Sometimes, I don't know if you've ever used a piece of software that told you can't undo, yeah? Or that tells you in advance if you do this, it's not undoable, for example. It's because they haven't figured out maybe how that might work. The other option, of course, is that if you're dealing with changes to something, then you don't care about what the individual commands are. You just know that anytime a command is issued, you just save the current state of the object on a stack, 2 stacks actually, generally. You have an undo and a redo stack. And then if somebody says undo, you just say, well, here's the previous version, or here's the previous version. Yeah, so there's 2 approaches there. And when we look at the results and the trade-offs, the result is that for both approaches to something like an undo and redo, then the end result is the same. We still are able to undo and redo, but how it happens at the back end may impact on the design and the performance of our application. So the consequences or trade-offs of choosing one pattern over another could be considerable. So for example, if you have a large diagram and you're just making a small change to that diagram, let's say you have a diagram like the ones that you've been doing in your assignments where you have 10 shapes, and you save the stack, you use the Memento, which is like keeping a version or stack. You push all that onto the stack, 10 shapes, it's okay. Let's say you're dealing with a huge drawing that has 1,000,000 shapes, and you put that onto the stack, and you just make them change to 1, and then you push it onto the stack. Every time you issue a command, you're pushing it onto the stack, pushing it on the stack. Soon you start running out of memory. You see that? You will use up all your memory if the items that you're actually saving on the stack are huge. And that becomes a problematic in terms of the resources. So sometimes that might not be a good idea to be able to do it that way, because it doesn't scale well. So you say, well, it would be better then just to be able to save all the commands. So if you save all the commands, then you have to be able to know, you can just save a list of commands and then apply the commands in reverse. That doesn't take up as much space, but it's much, much more complex, because knowing how to undo something is often very, very difficult compared to doing something. You know, I studied metalwork, and when I was a young fella, you know, and my metalwork teacher used to always tell me, you know, to measure it twice because you can only cut it once, you know. So you drill a hole, you can't undrill a hole in a piece of metal, you know, you just can't do that, for example, you know. And it's the same with certain software designs. You can do something and then undo it. So let's take, for example, if you have a command, issue a command that says changes all the letter A's in a document to letter B. So if you try to undo that using the command, then you say, oh, well, change all the B's back to A. Then what happens is you also change the original B's that were in the document as well. Yeah, can you see this? Yeah. So there are complications around this. Okay. So undos and redos, and this is why you're doing it in your assignment, okay? Because it's pain, right? It's awkward, it's horrible, it's messy, it's nasty stuff, you know? And that's why I like to give you things like this to do, to get you thinking about stuff and seeing about the realities and the complexities of messy software. Okay. Patterns are really useful, but there are trade-offs and consequences. And those trade-offs and consequences exist regardless of any implementation that you might do, how you might make it work. Okay, you need to be aware of those. In other words, you have to think and understand why you're doing what you do. Okay, it's really important. Okay, some some pattern catalogs list other useful details, maybe the applicability of the pattern, implementation steps in relation to other patterns, and they can include core examples that help grasp the purpose and the intention. And that's why I recommended that original book, because it's really super. You know, it talks about this pattern, and it does all of these things. It tells you about, you know, well, what this pattern is good for. Maybe you might consider an alternative pattern. You know, here's how you might implement it, some of the tricks or difficulties with implementing it. So we often hear about the GOF, the Gang of Four design patterns. You come across this when you were researching? Have you seen this before in any other subjects? Okay, Gang of Four, okay? So the whole concept of patterns was introduced by Christopher Alexander in this A Pattern Language, Towns, Building and Construction. This book describes this language for designing the urban environment. The units of the language are patterns. They describe how high windows should be, how many levels the building should have, how large the green grass areas is in the neighborhood are supposed to be, and so forth. Okay, so that's where all that patterns came about. The whole notion of patterns description. In fact, you know, Kildare County Council are having an urban development plan for Maynooth currently, and I presume you all saw the link, maybe coming from your student union, about driving and traffic and pedestrian work. You know, that's all about the patterns. If you actually look through that survey, it's all about the patterns, okay, as well. Okay, so this is nothing new, and it's been going on a long time. But the idea, from our perspective, the idea was picked up by 4 authors: Gamma, Vicides, Johnson, and Helm. And in 1994, they published this Design Patterns, Elements of Reusable Object-Oriented Software, and they applied the concept of design patterns to programming, and it features 23 patterns, okay, that solve various problems in OO design. It became a bestseller. Because it's a really long name, people just used to call it the book by the Gang of Four, and that was shortened to the GOF, or the Gang of Four book. So that's where that comes from. Okay. So according to these authors, design patterns are primarily based on following principles of OOD. Program to an interface, not to an implementation, and favor object composition over inheritance. Really have a look at that book at some point. I know I recommended another book, okay? And this older book might be hard to get and buy now, and it's probably a bit more expensive, but I think if you check online in the library, there may be a PDF version or an online version that you could have a look at. Okay. But there's core points here: program to an interface and not to an implementation. Always think about interfaces; they're really important, as I talked about when we were looking at Solid. And favor object composition over inheritance. Huge problems with inheritance, and we'll come across that as we move through the patterns a little bit later. Okay, how do you make new objects, basically, you know? And the patterns usually tell us a lot about like dealing and working with objects, okay, and the issues around those. So when we look at these patterns, then we need to classify them into the various groups. Okay, so the first one, and the most universal and high-level patterns, are architectural patterns, and then the developer can implement these patterns in virtually any language, okay, any language usually. Unlike all the other patterns that can be used to design the architecture of an entire application, the most basic and low-level patterns are called idioms, and they apply to a single programming language, so that's fine, okay. Then design patterns are said to vary in their granularity and level of abstraction. So because there are so many, there's 23 that we know from the Gang of Four, and there are more as well, okay? We need a way to organize them. So classification helps to learn the patterns in a catalog faster, and it can direct the efforts to find other appropriate patterns too. So the individual patterns can be classified into 3 different patterns. The creational patterns, they're all about creating objects and creating these data. Structural patterns, how these objects interrelate, work with each other, and behavioral patterns, how they behave in themselves in your application. And it's based on the design pattern intent or purpose. So if we think about creational design patterns, they provide and tell us about object creation mechanisms that increase flexibility in reuse in code. These patterns provide a way to create objects while hiding the creation logic rather than instantiating objects directly using the new operator. Okay. Generally, if you see a piece of code that's using lots and lots of new, if you see this thing, it causes problems. You try to minimize the amount of new created stuff. Okay, or you to be careful about how you look at this. So, It gives the applications real flexibility, okay, in deciding which objects need to be created for a given use. So for example, there's something called a singleton pattern, okay, and that is used to create a basic class, and it'll only have one instance. Common example is a global variable defined in the source code of a program, for example. Okay? The object pool pattern, that's used to create a class with a pool of objects, and that can be retrieved as needed instead of being recreated. And it's used for caching purposes. You see this in use in network applications when you're looking at databases. Okay? So for example, your program application starts, creates a pool, and allows you a certain number of connections to your database, and then you reuse. So you say, I want to make a connection to the database, give me a connection. So rather than creating a connection every single time, you take an existing connection, because there's a huge amount of overhead in terms of connections, and sometimes databases, like Oracle, for example, you will pay on a per connection basis for the access to the software. Okay, so you know your application, which runs in the background, say your web app, you know about this already. If your program, and we didn't get a chance to do this when we looked at CS230, because we hadn't done design patterns in second year, then every time people connected, they made a connection to the database. But if we've loads of people making the connection, then the database crashes. It can't handle this, because there's a huge amount of overhead in making that connection. It's better to have a pool of connections. You say, give me a connection that exists already, okay? And then you can pull that information using that connection. When you're finished with that connection, somebody else has given me a connection, you can give them that connection. Okay? So if we were to do CS230, if we were doing a CS330 now this year, we would all, we had the benefit of our patterns, we would redesign and build different kinds of software. Okay. Anyway, we are where we are, you know, and you can look at that and research it yourself. Let's look at structural patterns, and they explain how to assemble all the objects and classes into larger structures while keeping all the structures flexible and efficient. Now, this is no different to the solid stuff that we talked about before, how we start combining all of these classes. They're concerned with class and object composition. And we know that about inheritance. So inheritance is used to compose interfaces and define ways to compose objects to obtain new functionality. So you may see some, if you look at some of the solid examples that I've given for the last week's lectures, you will notice that there was a move away from classes inheriting from other base classes. A lot of the time I was looking at how do you inherit from interfaces. Yeah, so it's all about implementing interfaces. And that's really an interesting way to look at that. So I was moving in some respects away from inheritance to just implementation of interfaces. So the concrete classes implemented some kind of interface rather than being in a class hierarchy where you had an abstract class and then you extended it, produced a concrete class in that way. Structural design patterns define the relationship between the objects. The decorator pattern, for example, allows behaviors and states to be added to an object at runtime. That gives programmers with the flexibility to add as many classes to an object as needed, and it essentially creates a decorator class which wraps the original class and provides additional functionality, keeping the original class method signature intact. And this is like you think about the solid, you know, we're doing something with this class, we don't change it, you know, essentially you're creating a new class, or you might be creating subclasses sometimes. We don't want to change the behaviors. So once behavior is done, we don't want to change that. That was the listcoff. Remember in solid we said if we have a class and it works, then we should be able to replace it with any of its subclasses without changing the behavior of the application. Think back to these, you know. An example would be character in a video game that accumulates items. For example, if you play a role-playing game, you have weapons and armor and all that kind of stuff. The decorator class could give a good framework for that kind of process. That's how they do this. And then we have the behavioral design patterns. And they manage effective communication between and the assignment of responsibilities between the various objects. They're concerned with communication between objects, and they characterize the way in which classes and objects interact and distribute responsibilities. So these are like the methods that essentially are ultimately called. So two examples, we say, command and memento patterns. They can be both used together or individually to perform undo or redo operations in a program. We didn't see commands too early. We look at it now. The command design pattern describes objects that execute commands. And the Memento pattern records the state of an object so it can be restored to its saved state. Sorry, that should be state there. Just escape there. Just fix this. Now, and we'll change that. Because we didn't, I think. I think what's important to remember is that we can actually use, if you were thinking about what I said, that sometimes we might have an issue where we want to use the command pattern, and then sometimes we'd want to use the Memento pattern. I didn't say to you that you could actually use both patterns if you wanted as well. So you may have different ways or different situations within a big application as to when you may use command and when you may use Memento, but you might actually be using both. Okay. We actually, if you think back to our web development, we did talk about model view controller. So we were looking at variants of this called MVM, MVVM, etc., model view model and model view view model. And you would have heard me referring to those as a pattern when we looked at web dev. So what kind of pattern are they? Are they design patterns? Are they behavioral, creational, or structural? Okay, because it's important to think about these. So I actually said at the time that there were architectural patterns. They're not design patterns. Okay? At the beginning, a few slides ago, I talked about architectural patterns and they were slightly different to design patterns. Okay? So what's the difference between a software design pattern and an architectural pattern, and are they the same thing? So design patterns differ from architectural patterns in their scope. They're more localized, they have less impact on the code base, and they impact on a specific section of the code base. So architectural patterns solve the problems related to an architectural style. And architectural patterns have this extensive impact on the code base by impacting on the whole application, either horizontally, how to structure the code inside the layer, or vertically, how to request this process from the outer layers to the inner layers and back again. So model view controller is this example of this architecture pattern. They provide a recurring solution to a recurring problem. They distinguish between design and the architecture patterns, all about the scope. Okay, and I have a blog post here which tells you a little bit about the difference between architectural styles and patterns and design patterns. It's worthwhile having a look at that. And Ezra Lazzardi also wrote this article on design or architectural patterns, discussing the difference between both kinds of patterns. It's worth reading. It refers to situations where you find conflicting information from trusted resources. Okay, that's good too. So relation software development, architectural patterns describe the components interaction, while a design pattern explains how each component is built or would be built. So there are architecture patterns and there are design patterns, and both of them are different. And I think it's really important that you think about that, okay? Because you could actually be asked in an interview, is give me an example of a design pattern, and you might say, well, I know MVC, so I'd say MVC, when actually it's an architectural pattern. Or you might be asked to give me an example between an architectural pattern and a design pattern, and you could talk about Memento and command as being your designs, and you could talk about MVC as your architecture pattern. Okay, that article is really good. So with creational patterns, here's the list that we have from the Gang of Four. They provide object creation mechanisms, and they increase the flexibility and reuse of existing code. Abstract factory, builder, factory method, object pool, prototype, and singleton. And they're all about giving you objects that you can use in your program. The structural patterns, they recommend how to assemble the objects and the classes into larger structures, keeping the structures flexible and efficient. These include adapter, bridge, composite, decorator, facade, flyweight, private class data, and proxy. Okay. The behavioral patterns describe how to manage effective communication and the assignment of responsibilities between the objects. And these include the chain of responsibility, command, interpreter, iterator, mediator, memento, null object, observer, state, strategy, template method, and visitor. There are 23 patterns. The recommended text actually describes 22 of those patterns. Okay, interpreter is missing, but it also includes a non-gang of 4 pattern called the private class data pattern. Okay, just not all books give you all the information. So I give you, this book, it's great, it's brilliant, and for what it's worth, but it doesn't actually talk about the interpreter pattern. Okay? That may or may not be an issue for you. Okay, probably won't be, but it doesn't do everything. It's very hard to get everything in one book, in one place. So let's think about memento and command. So you have this assignment that requires this undo redo functionality for console-based CLI or command line interpreter interface. So I think you should consider one of the gang of 4 patterns, command or memento, for your design. It's in the assignment 4, as I mentioned already. Now, I did ask you to do an undo redo previously, as I said, and I did mention in that assignment that there were memento and command as well, that you should be looking at some approach, but you may have got any approach. In fact, most people, when I looked and talked to them, they were looking at memento. Even if they didn't realize they were doing memento because they were using a stack and they were keeping information on the stack, and then they were pushing things on the stack and popping it off the stack. Essentially, they were looking at a memento approach. So the memento pattern then just stores the snapshots of the composite object state. So in other words, your canvas that contains the states, you're keeping a snapshot of those states. The command pattern then, instead of storing the full state, stores the difference between the states. And the difference are stored as actions. In your case, these would be the UI commands. They can be applied and unapplied. When introducing a new action, apply and unapply needs to be implemented then. So with command, like this kind of command here, okay, a lot of direct manipulation interfaces. These commands here allow you to do something. It turns a request into a standalone object that contains all the information about the request. And the transformation lets you parameterize the methods with different requests, delay a queue or request execution, and support undoable operations. That tells us really what the command is. And Memento lets you save and restore the previous state of an object without revealing the details of its implementation. So you don't know what the command was that made the change. With Memento, you don't care. All you want to do is be able to bring you back to that previous state. Okay? That's all. You save the state and bring it back to that state. Okay? But with the command, you actually need to know how to undo the command that you've actually done. Yeah? That becomes interesting. Okay? It's a bit harder to do, worth doing. When it comes to your final examination in the coding exam, I usually ask people to implement both. Okay? In the coding exam, I ask you to provide a solution that does a task and to replace the undo redo. So choose a piece of software that requires you to write a piece of software that has an undo redo functionality using command, and then to actually take out the command section of your software and replace it with Memento. So you will have to do both, and you'll have to know both. Telling you now, you need to do both and have to do both. And you'll have to design it in such a way that you will be able to swap a different approach in and out. So what does that tell us? That tells us that the design of your software has to be built in such a way that the undo redo functionality can be swapped in and out, and you can replace that with some other approach. It's really crucial. So once you know in advance, I'm going to have to show 2 ways to do this. It means that if you built everything around one way and it was highly coupled, really tight, highly coupled, then it means you have to redo everything. So you have to have loosely coupled design that allows you to be able to build a piece of software that has an undo redo, has a menu type system that does this, and yet it allows me to remove all that piece of code and replace it with a different piece of code and not change the functionality of the program. That's where students lose marks in the coding exam. They can write one part and get one part working, great, but they're not able to undo that and replace parts of it because it's also tightly coupled. And this is a software design, and you say design and write a program, design and develop a software. You'll see this. You see these words in my assignments. The reason I say design and develop is you have to design and develop, and the design means that it's able to handle change. Now, of course, some people do actually just do both, you know, and I still give them the marks, you know, because they've worked hard and got the solutions. But they might lose a couple of marks for not being able to replace it. So it's really crucial for you that you're able to do this. So when you use undo with command and Memento, if you use Memento to manage an unlimited history of our application, it's straightforward, more intuitive, okay? It is, and that seems right, okay? But sometimes, so every time a history entry needs to be generated, we crop our history list to the current position, take a snapshot of the current state, and append it to our history list. And that's independently of any actions that would be worked, okay? And so, our current state, undo and redo. This is a little bit, so we know we have the state, we're able to move back and forth. Sometimes you see this one with two lists, okay? The undo list and the redo list. And with Memento, that's quite nice. If you use command, all the information to perform the action is encapsulated in some object, okay? So you have these command objects that you unapply to the current state, or you apply to the current state. So whenever an action is performed, the action and its reverse are first encapsulated into an object. That object's applied to the model state, changing the model, and afterwards pushed onto the undo stack. And at that point, the redo stack is also cleared since the information is now outdated. There's a couple of stacks there, yeah? So I think it's quite nicely described in this article here by Lucas Simon on solving history. It's a hard problem. So this is the kind of thing you need to be thinking about with your program. We'll finish it in less than a minute, okay? And I'll continue with this description of the actual patterns in the next lessons, which I'll pre-record and upload for you, okay? Lecture 16. You need to decide on one of these approaches, okay, and apply it in your in your assignment. Choose one approach, and I'm happy, and you'll get full marks. There's no prejudice here in terms of your choices. You know, I don't favor one over another. You know, choose one and implement that one. Okay. Then compare it with the assignment that you did last time. Look at it and see how it works. Okay. Look at the formal design pattern, which will come in the next lecture, and implement that pattern. The pattern is described in the book. It's on that refactoring.guru website. You can have a look at the C# there. It's in other places as well. Choose one and then make the comparison. Okay? But remember, in the final exam, coding exam, you will be asked to implement both. So you need to know how to do the other one as well. Lots of ways to do this. You could have a coding buddy, you know, and then like one of you do one and one of you do the other and then swap over and see how it goes. You know, there's ways to learn this. You know, that's quick. You know, look at somebody else's. And say, you know, there's ways to, but do it. You still need to know your own, okay? Still need to know your own one. Okay, of course you do. Thanks for coming, and remember, no tutorial today, and good luck with the assignment, and apologies again for the error. I'll upload the correct version just after this class. Thank you very much. Bye-bye.